This is the AM5N strain wave mount, and it's the latest in ZWO's lineup of portable equatorial mounts for astrophotography. And true to its strain wave design, it's compact, lightweight, yet it can support a lot more weight than its physical size might suggest, all without needing a counterweight, which does make your setup time easier and faster whether you're imaging at home or escaping light pollution for darker skies. Now, compared to the original AM5, the AM5N now supports larger payloads without a counterweight, and it has improved tracking accuracy for long exposures with reduced periodic error. Notable hardware upgrades have also been made, like a redesigned base for easier polar alignment and integrated cable management. Of course, that's not all, so in this video, we're going to check out everything that this dude comes with. We're then going to dive into the features and specs and see how this mount compares to other mounts out there on the market. We'll then finish things off with seeing how this dude performs in real-world tests. Alrighty, I'm Sarah Matthews, and as always, grab a snack and let's jump into it. A quick disclaimer before we begin, ZWO did send me this mount for review, but as always they have zero say over the content of this video. And as with any review that I ever do, my hope is that it just genuinely helps you in your journey, wherever that it is that it takes you. So just like the original AM5, which came out in 2022, the AM5N is a portable equatorial mount that, after almost 6 months of testing, I think it's going to check your boxes if you're looking for something that is portable, has a high payload capacity, is relatively easy to set up, and has reliable performance at a relatively competitive price point. Now, if you're new to equatorial mounts, they are the gold standard for astrophotography because they are designed to compensate for the Earth's rotation, which means they can keep your target perfectly centered in your field of view all night long, just like the song. That makes them ideal for taking long exposures over long periods of time, which is ideal if you're trying to image very faint objects like nebulae and galaxies, which require lots of integration time or lots of light to be collected to reveal their faint details. Now, one of the factors that makes the AM5N stand out compared to other traditional equatorial mounts, like the one behind me here, is its use of strain wave gears, or sometimes called harmonic drives, to control the axes of the mount. And strain wave gears are used in a lot of other high precision fields like robotics and aerospace, but with an astrophotography mount, strain wave gears provide a balance of being both lightweight yet very powerful, which is a result of its high reduction ratio and high torque. So despite its small size, the AM5N can support payloads up to 33 pounds or 15 kilograms without a counterweight, which is a pretty nice bump from the original AM5's 28-pound capacity without a counterweight. But if you do want to use a heavier setup, you can use a counterweight with this, and your max payload capacity is going to be 44 pounds. Using a counterweight is more so just to keep the balance of everything so the mount doesn't tip over. Aside from having a high payload capacity and being lightweight, strain wave gears are also pretty tolerant of imbalances, which means that you don't have to precisely balance the axes like you do with a star tracker or a worm gear mount like the one behind me, which does make your setup time a little bit easier and a little bit faster. So whether you're a beginner and you're looking for your first equatorial mount, or you're moving up from a star tracker, or maybe you're like myself who already has a traditional worm gear mount and wants something a little bit more portable, I do think strain wave gears are at least something to look into. So that was kind of the high level overview. So now we're going to get into everything that comes in the box with this mount. The AM5N comes with a quick start guide for getting started, and true to its name, it is a very quick read. Next, we have a periodic error test report for this specific mount, and periodic error just refers to small deviations in tracking. So ZWO is reporting that the new AM5Ns have better periodic error than the original AM5's plus minus 20 arc seconds, so they're saying it's down to plus minus 10 arc seconds of total error, which basically means it has better tracking, which does result in better overall guiding performance, but whether or not that holds up in real-world performance tests, we will of course see. So the AM5N comes in this carrying case. It's a hard foam gray carrying case, or gray black. I've taken this on 2 road trips now and packed a lot of things around it, and it's held up really well. I like that the form factor is, small enough where you could take it on an airplane, but it's also really easy to store and just carry around. There is a carrying little handle here. So to open it up, we would be using these kind of briefcase-like clutches or locks. We have a foam cutout for a counterweight bar, which the AM5N does not come with. We have the hand controller here. We also have a hand controller cable, this little doubler. We have a couple more cables, which I know are invigorating to the soul. We have a 2-meter USB-B to USB-A cable. And new to the AM5N is a USB-C to USB-A cable, and it's 1 meter long. So that's cool. We're going to talk more about that later. We of course also have the mount head here. It stays securely in place. It doesn't move around or anything, but it is pretty easy to get out. And then inside of the mount, we have a magnetically secured hex wrench, this little guy. The AM5N does come with a 2-year warranty through ZWO. Overall, no complaints with the carrying case. So now let's get into the features and specs and see how this little dude compares to other mounts out there on the market. So here we have the AM5N mount head out of its case, obviously, and it is currently sitting atop of the optional PE200 Pier Extension, which is then sitting on top of the TC40 carbon fiber tripod. So the AM5N is compatible with any 3/8" tripod. It does have a 3/8" hole at the bottom or on its base, but there are also 3 M6 screws on the bottom of its base as well, which is used to add a quick release mount head plate, which the TC40 and the Pier Extension both come with. And the quick release mount head plate is really nice because you can just quickly, as the name kind of implies, move the mount head to whichever position you would like and also take things out and just move things around pretty quickly. Next, let's talk about the aesthetics of the AM5N. In my opinion, the AM5N does have a really nice, sleek, modern look going on and a very cute, compact form factor, the latter being the most important. But the red and black paired with the white and silver accents is both fashionable and functional. I find that the red is subtle enough that it doesn't draw too much attention to itself at night, which I think can be a really big advantage if you're imaging in an open space or maybe a less secure area, while at the same time it's still visible enough that if you do know where to look and you want to check on your setup either from your house or your car or your tent, you can still see it without having to shine a big old bright light during your imaging session. I do also find that the contrast of the colors work really well together in low light conditions, so you can still use the mount pretty easily. But if you are into having more color options with your mount, you can check out other brands like Rainbow Astro or Hobum Crux. But anyways, now we're going to move on to talking about the build quality, because the AM5N does feel really solidly made and high quality, and the internal components like the motors, the gears, the belts, the electronics are secured in airtight areas, so that should help maintain their integrity to some extent. The AM5N is made out of aluminum mostly, with some other types of metal throughout and hard plastic. The mount is mostly covered in a powder coated finish. It is holding up pretty well, although there is some slight wear and tear here on the back of the Dovetail saddle, which is kind of a bummer, but a loss. The red is slightly different than the other mounts that I have here behind me, the AM3 and the original AM5 there, which I do think gives this a little bit more of a added flair of sophistication, if that matters. And yeah, in terms of its dimensions, they are very similar to the original AM5. The AM5N does weigh in at 5.4 kilograms or 12 pounds, which is very similar to the original AM5 here. But I did want to provide some added perspective in terms of how this mount's dimensions compare to other mounts and star trackers that I have throughout the vicinity. So we have the EQ6-R Pro. It is a traditional German equatorial mount with worm gears. It is really a workhorse of a mount, and I absolutely love mine. I've had it for years with really no issues ever. So it is really nice, but it is also very large. The mount head alone weighs 40 pounds, and it does have the same payload capacity, or the max payload capacity, as the AM5N with a counterweight, except with a worm gear mount, you do have to use a counterweight regardless of the payload capacity in most instances. Otherwise, you will strain the gears and the motors and basically impede your tracking performance overall. But if you are like myself and you don't have your own permanent observatory outside or a permanent pier, so you do have to set up all of your stuff and take it down each clear night, well, you know, sometimes having a little bit of a smaller mount is helpful on the old back here. But yeah, if you do have something that's permanent, then sometimes just keeping the other one is totally a great option as well. Otherwise, having something portable at home for those reasons is nice, also for storage purposes, as well as if you're going to be, you know, heading out somewhere to darker skies. Now we're going to talk about some star trackers. So yes, this is a very small star tracker. It is the Move, Shoot, Move NOMAD star tracker, and this is usually what you would use for doing something like wide field Milky Way shots. This of course does not have the same payload capacity as the AM5N, but I'm just trying to show you some comparison for dimensions. And then of course we have the fan favorite, which is the Skywatcher Star Adventurer star tracker, and I do have the declination bracket on here, but I don't have the counterweight kit installed. But if I did, then that would be the configuration I would use with a telephoto lens or a small refractor for taking pretty wide field, deep space images. But this does have a much smaller payload capacity than the AM5N, and it does not have a motorized declination axis, so it's really not going to be all too great for taking super long exposures or for using telescopes with longer focal lengths. So that is one limitation, is having only the RA being motorized. And also the Star Adventurer is pretty close in size to the Ioptron Skyguider Pro, just for reference in case you're like, how do these, compare in size? And then of course we have the Skywatcher Star Adventurer GTI behind me, which is a little bit more of an advanced mount in terms of its capabilities. It has GOTO functionality. It does have the same payload capacity pretty much as the Skywatcher Star Adventurer, but it does have dual motorized axes, so that is a plus. But it does have a smaller payload capacity than the AM5N, and it does require counterweights to function. Now for something kind of in the middle from a star tracker to the AM5N, we have the AM3 here. And the AM3 is a really nice tracking mount. It does have a smaller payload capacity and is slightly smaller than the AM5N. It doesn't include some of the features that I think make the AM5N and the original AM5 more portable, which we're going to talk about a little bit later. So yeah. And I know that I don't have any of the competitor strainwave mounts with me here, but in terms of the ones that I have listed on the screen, they are all pretty much the same size-ish and do have similar payload capacities with kind of differing price ranges, and there are some notable feature differences as well, but we are going to talk a little bit more about those things later on. Alright, now let's dive into the AM5N's dual functionality. So it is primarily a motorized equatorial mount with motorized right ascension and declination axes. However, it can also function in Alt-Az tracking mode. And Alt-Az is going to be great for using this for visual astronomy. You can switch between the modes by using the hand controller and pressing the cancel button until this little status light on the front here turns from red, which means EQ mode, and turns to green for Alt-Az mode. For Alt-Az mode, you would want to change the base here to 90 degrees so that the axes can move independently. The AM5N's 0 degrees to 90 degrees latitude base here does allow you to image anywhere on Earth, whether you're at the equator or at the North Pole, for example, which is pretty cool. The range is broken down into 2 gears. Gear 1 is for latitudes from 0 to 60 degrees, so perfect for imaging at mid-latitudes. And then Gear 2 is for 30 degrees to 90 degrees, which is going to be great for higher latitudes or for if you're choosing to use this in Alt-Az mode. Now I really like the repositioned altitude scale. Before it was on the side of the original AM5, which was kind of awkward. There also wasn't this nice little convenient arrow pointing to the latitude that you were at, so you kind of basically just had to kind of guess with the little screws here to, again, guess which latitude the pitch angle was at. Now, if you're used to polar aligning a star tracker or a traditional equatorial mount, the process is going to be very, very similar. That there is one notable difference, and that is that you are not going to be able to polar align this mount with a built-in polar scope, because there is no built-in polar scope. So if you're used to looking through a reticle and making your fine-tuning adjustments that way, you are going to have to find another way, but I promise it's really easy and really straightforward, and you're probably never going to look back or ever want to look through a reticle again, especially for people out there who have glasses such as myself. But anyways, you kind of have 2 options. One option is to use something like the QHY PoleMaster, which is a digital polar scope that you can mount to the front of your Dovetail bar here and just use some software on a laptop or a mini PC and make your fine-tuning adjustments to polar align the mount. Otherwise, you can use something like a ASIAir, where your main imaging camera, like a DSLR or mirrorless or dedicated Astro Cam, becomes your polar scope. Those routines are very easy. You can also use something like Nina's 3-point polar alignment, which also works great. But that is just something to note, because that will change your workflow if you are used to not having to use any other type of device to polar align your mount. Now, not having a built-in polar scope is pretty standard these days. Most manufacturers assume that you're going to be using power anyways with these mounts, as well as software for acquisition, so why not just use your other types of software means to polar align this mount. Although I would like to mention that some of Ioptron's strain wave mounts do come with iPolar built in, so if you are looking for that type of option, Ioptron would be something to look into. Now, when it comes to making fine-tuning adjustments, I generally start with altitude first, so I make sure that the altitude locks are just slightly loosened, not too loose, or else these things can just spin off, which is not ideal. Also, you don't want them to be too loose, because when you do tighten them up, you don't want to have any sort of backlash when you are finalizing everything. But the fine-tuning adjustment knob for altitude is this little metal rod here with these kind of two ball bearings. The mechanism itself is very similar to the EQ6-R Pro, with a center rod that basically lifts the altitude or decreases the altitude of the mount. And so you just move it this way or this way, depending on what your polar alignment routine is telling you to do. It's very smooth and very precise. You don't overshoot really at all, as long as these are just slightly tightened. And you can clearly feel how well this was machined, which I think is a big plus. And I think that this overall just works really well for overall user experience. Now, at some point you are going to need to lock the altitude locks again, but moving on to the azimuth fine-tuning adjustment knobs, they are right here. They do also function very similarly to the azimuth kind of configuration knobs of a star tracker or the EQ6-R Pro. You have two opposing screws basically that's going to be, moving it in one direction, locking it in the other. One thing that you may notice is that there are no azimuth locks on the base here like there are on the original AM5. The locks have been replaced with these spring tensions instead here on the base, which helps to keep the movement possible, but keeps everything in place. I haven't had any issues with them, and I really like it. I also didn't really like the azimuth locks either, because what would happen is that you'd be fine-tuning everything, then get everything good to go in polar alignment, and then lock those things in place, and then your polar alignment would change. So I think that was a good design choice. Now, in terms of just the knobs themselves, they work really well. They're very responsive. 10 out of 10 for those as well, no issues. In terms of the azimuth adjustment range, it is ±6 degrees of movement compared to the original AM5's ±10 degrees of movement. So if you haven't just done a rough polar alignment with your compass app on your cell phone ahead of time, I would highly recommend that you actually do that. Otherwise, you may run into issues where you don't have enough range going in one direction or the other in azimuth, so you will have to, move your tripod. But if you do have the quick release adjustment plates or quick release mount head plates that I mentioned earlier, you can just, unlock things and move it as such, and then lock things back. To power the AM5N, the mount uses a standard 12-volt DC amp input with a 5.5 by 2.1 millimeter center positive connector. You can either plug it in on the front here, which supports a maximum current of 5 amps, but you can also use the power port on the Dovetail saddle, which is both a power in and out port. The DC port on the Dovetail saddle requires a minimum current of 3 amps when used as an input port and supports a maximum current of 5 amps when used as an output port to power your accessories. But the port here on the Dovetail saddle is really nice for cable management, so if you do like to use something like a Pegasus Astro power box on your telescope, for example, that's really nice because you can just have one cable basically running up. The original AM5 did have a DC power out port, but it was on the side, which was a little bit more precarious for cable management, but it was still nice to have the through the mount power nevertheless. The mount does have a relatively modest power draw, but it does align with pretty much everything that I've read online from ZWO and from other users. So here they are on the screen. But to power the mount through AC power from your house, for example, you will want to use something like an AC to DC power converter like this that I have here. This is from ZWO. I think it's around $32 US, so it's not massively expensive. The AM5N does not come with any way to power it, so you will have to find some means to power it. Now, one thing to mention, if you are upgrading from a star tracker like the SkyGuider Pro, for example, the AM5N does not take rechargeable batteries, nor can it be charged in any sort of way. So that does mean you are going to have to find some sort of portable power source otherwise. So the one that I like to use is this Apertura all-night imaging supply. It works really well for powering the AM5N, all the accessories that I use, all night with no issue. Another thing I want to talk about is that if you are looking into something like the AM3 does not have the power out port, so you will have to find some other way to power all of your other accessories instead of powering them through the mount. Now to turn the mount on, it's pretty simple. You of course have to have it connected to power, but then there's this little power button here on the side, and it will greet you with a very friendly hello via beep. And if you don't like the beep, then you can just turn that off in something like the ASIAir, for example, and it'll also turn red. So to control the AM5N, there are lots of different ways, but probably the easiest way and the most direct way would be through the hand controller, which is this little guy here with its hand controller cable that you would just plug into the front. Now with the hand controller here, you can move the axes simultaneously, you can tell the mount to go home, you can switch the tracking modes from EQ to Alt-Az, and it's going to be great if you're going to be using kind of these quick setups for doing like visual astronomy, if you want to do just kind of some quick alignment to get something centered up in your field of view, for example. And I've also used this to take flats, so when I've wanted to just put a flat panel on top with the mount facing up. There is no place to put the hand controller really, so it kind of just dangles off of something like this, which is a little bit of a precarious situation. That's kind of the biggest fault. But the hand controller does have built-in Wi-Fi, so that's going to be nice for doing your firmware upgrades. It does have its own network that's going to be on the back here with its own password as well, which can be changed later on. While this is connected, you can also use things like the Sky Atlas mobile app or use the ASI mount ASCOM software as well to control the mount. So talking more about the Sky Atlas mobile app, this is going to be nice since the hand controller here does not have a kind of screen interface that you might be used to with something like the Sync Scan hand controller. But the Sky Atlas mobile app is a way for you to control the axes of the mount just like this. You can also perform GOTO, you can do lots of different things with it. There's a planetarium sky view built into it as well. And you can connect to the mobile app either with the hand controller plugged in, or you can connect via the Bluetooth connection method that is built into the mount. I've used Bluetooth with this mount and it works perfectly well. No issues connecting or switching between Wi-Fi or Bluetooth. So using Bluetooth is going to eliminate, this whole cable and hand controller mechanism. What's also nice about having Bluetooth is that you can use the Sky Atlas mobile app without having to have the hand controller plugged in. So that does free up your Wi-Fi or cellular network on your mobile device as well, so that if you wanted to check out the internet on your phone while using this for whatever reason, like to check on some cool facts about Saturn or to troubleshoot, you can do that. Now, for more advanced workflows, the AM5N does support multiple different types of software to control the mount. It is ASCOM compatible as well as Indy compatible, and I've used this mount with Nina, for example, but you can use it with things like Sequence Generator Pro or Voyager, etc. But with Nina, at least, I haven't had any issues while launching the ASIA mount server and Nina at the same time. Nina will work seamlessly. There's no issue there on my end, at least. And of course, you can also use the ASIair, this little device over here, which works seamlessly as well. To connect to the ASIAir or to a mini PC or a laptop or a computer, there is a Type B USB port on the front here, and there is also a Type C data port on the back here on the Dovetail saddle right next to the DC power port. So that does support cable management, which is really, really nice. Now, speaking of the Dovetail saddle, so yes, it has been redesigned to support cable management. A USB-C port and a relocated DC power port are now built into the Dovetail saddle, reducing the risk of cable snags. Internal cabling on the DC axis has been redesigned to handle 360-degree movement, and the Dovetail saddle itself is a hybrid design, supporting both Losmandy D and Vixen Dovetail mounting plates right out of the box in a single interface, rather than needing to install or uninstall different plates like some other mounts do. The dovetail length is 5.2 inches, which is nice. The saddle includes a spring-loaded safety lock system that maintains grip even if the main clamps aren't fully tight or if there are temperature shifts throughout the night. So yeah, it does work really well. I haven't had any complaints with it so far. Alrighty, now let's talk about the payload capacities of the AM5N. So just like other strain wave mounts, the AM5N can support a lot more weight despite its physical size. Without a counterweight, the AM5N can support payloads up to 33 pounds or 15 kilograms, and that is an upgrade from the original AM5's payload capacity without a counterweight, which was 28 pounds. This improvement is likely due to the enhanced strain wave gears themselves in both axes, as well as the larger stepper motor in the deck axis. But again, the AM5N can support payloads up to 44 pounds when paired with a counterweight. I will be using this extension bar from my EQ6-R Pro over there. The AM5N does support M12 threads, which you can find located on the bottom of the mount here with this little silver stopper shoe removed. We just are going to add this to the bottom. The maximum weight of a counterweight that you can use is 11 pounds or 5 kilograms. So this is the counterweight that I'm going to be using. It is 11 pounds, I believe. And conveniently, this little stopper shoe that the AM5N comes with does fit on the bottom of little counterweight bar. You can just thread it into place. Now, balancing the mount is going to look a little bit different than what you're used to with the Star Tracker or the EQ6-R Pro. You may have noticed that there are no locking levers for the RA or deck axes. And locking levers are not there for a couple of reasons. One, the gear reduction ratio of the gears themselves do hold things up pretty well. But if you did want to balance the axes, for example, because you wanted to make sure that the power output is well within the range that you would expect, then you can balance the axes, specifically the deck axis, where you would just move your payload up or down depending on the center of gravity of your entire imaging payload. However, to be honest, with a RedCat 51 or something a little bit bigger than that, I haven't really found too much of a difference if I've really balanced the deck axis or not. But with a larger payload, you might want to be more mindful of it, just depending on if you are using a counterweight or not. As long as the center of gravity is 20 centimeters from the rotational axis of the mount, you're probably going to be just fine. Now, some strain wave mounts out there do have locking levers for the axes. Sometimes it's actually just one axis. Sometimes it is both axes. For example, the Skywatcher Wave 150i does have locking levers for both the RA and deck axes. However, they are only used for balancing. They are not used for pointing like you would point the axes of a Star Tracker or a traditional German equatorial mount, which means that to move the axes, you do have to rely on some sort of powered method of control, like the hand controller, for example, or the Sky Atlas mobile app, where it has little buttons that you can move the axes, or you can rely on the ASI mount software or through the ASIair's little buttons to control the axes. Most of these control interfaces that you're going to be using are going to have some sort of go-to functionality, and a lot of them are also going to have plate solving capabilities. So if you are someone who just likes to take out their mount and telescope very quickly and set things up and then move the mount's axes to find the moon and look through the eyepiece without having to power everything on, then this is going to kind of be a little bit of a different workflow than you're used to. We're going to now formally talk about slewing and GOTO with the AM5N. So with the hand controller in hand, just move the telescope in all sorts of different directions to make sure that nothing hits the tripod legs, nothing hits the ground. Use the joystick to make sure that all different angles are safe. And then once you're good to go, then bring everything back home and then you can perform your GOTO. Now, if you do need extra clearance, again, then I would recommend getting something like a Pier Extension so that you can avoid any sort of collisions with your tripod legs. So the AM5N does have a max slew speed of 6 degrees per second. You can also change the slew rate to these different types of slew rates that I have on the screen here. Now, for those of you who fancy some ASMR, the GOTO and plate solving methods that I've been using with the AM5N have all worked really well. There hasn't been any issue. Just make sure that the AM5N is in its home position before you do anything else. And of course, make sure that it has good polar alignment if you're using this mount in EQ mode. That being said, it is very important that you start off in the home position, which obviously without clutches means you have to find the home position some other way. You can bring the mount back to its home manually by just doing a one-click go home function, either through the hand controller or through the Sky Atlas mobile app that I have here, or through the ASIair, or through the ASI mount software, or through Nina, for example. You can also automate the return to your home position by adding that to your imaging sequence, like in Nina or ASIair, for example. So once the imaging plan completes, the AM5N will go back to its home position. So the way that the AM5N knows what its home position is because there is a homing sensor in the RA axis, and there's also a homing sensor in the deck axis. And homing sensors are just really nice to have in a mount, even if your mount does have manual clutches. And that's largely because if you fully automate your setup, for example, and use it at home, it's just nice to know that the mount is always going to know where it is, especially also if you do send your mount to a remote observatory. Homing sensors are also really important to have for power loss recovery. So for example, if your mount is tracking and then all of a sudden power is lost, then once power is recovered, then the mount will go back to its home position. So that's going to tie into the AM5N's brake. there is an electronic brake in the RA axis. So that's why when you turn off the mount, you're going to hear this little clicking sound. And then when you turn it back on, you'll also hear the lock as well, because that's disengaging and engaging the brake. Now you might be wondering why the deck axis doesn't have a brake on it, and that's because the gears themselves are naturally holding a lot of torque, so it's not really that necessary as long as you have a pretty balanced load and are within the limits of using a counterweight or not. And also, since the deck axis experiences less force during tracking compared to the RA axis, it's really just not that necessary. But again, within its limits. All right, now going back to the homing sensors and just the kind of whole home position thing, if you do notice that your home position does get out of whack for whatever reason, you can calibrate it in the Sky Atlas mobile app. As another note, if you're looking to define your own park position, you're gonna have to do that in something like Nina, because the ASI Mount ASCOM software does not allow you to define what the park position means in the software itself. The park position for the ASI Mount ASCOM platform is only where the dovetail saddle is horizontal to the ground, which is going to be useful if you're using the mount in alt-az mode and you do need to add your telescope. So just something to note. Alrighty, now let's get into the tracking and guiding performance. So the AM5N's overall tracking performance has improved compared to its predecessor, the original AM5, a key factor here being what's called periodic error, which I kind of brought up the term a little bit during the What's in the Box section when I brought up the periodic error test report for this specific mount. But again, periodic error just refers to small angular deviations caused by imperfections in the mount's gears. They are usually measured in arc seconds because this unit directly corresponds to any sort of angular shift that would change in the field of view of the telescope due to these deviations. So even minor deviations can impact the sharpness in long exposures, for example. So on the AM5N, periodic error is plus minus 10 arc seconds compared to the original AM5's plus minus 20 arc seconds, which we can see in this periodic error test report that I have right here. So the maximum periodic error for this mount is 11.5, whereas the original AM5 that I have in another room right now has a periodic error, or a max periodic error of 26.2 arc seconds. So something like the Skywatcher EQ6-R Pro may have something on the order of plus minus 25 arc seconds of total error, but because they use something called periodic error correction, or PEC for short, they're able to bring the periodic error overall down to around 5 to 7 arc seconds. So something that a lot of worm gear mounts have is called backlash, which is basically a delay in the gear's movements. Strain wave mounts like the AM5N do not have backlash, at least with its gears, but there is backlash with the belt. So the belt is connected to the stepper motor, which basically drives the harmonic drives. Personally, I have not noticed any sort of issue with backlash with the belt. For those who have experienced it, I think it's because they just needed to make the belt a little bit tighter, but yeah. So while strain wave mounts are lightweight and very portable and virtually backlash free, they do require auto guiding for the most part to perform at their best during long exposures. And this is going to be true for most strain wave mounts, just like the AM5N, that do not have high precision encoders. And high precision encoders would allow you to use the mount unguided because they have such a high level of accuracy, because they can correct at such a high degree of accuracy. But high precision encoders, or sometimes called absolute encoders, do come at a premium in terms of cost. You can get them in a worm gear mount, you can get them in a strain wave mount, you can get them in something like the Ioptron EC series. So for most astrophotographers like myself, I do rely on auto guiding to make sure that the mount can perform at its best. But essentially auto guiding is where you would use something like a guide scope like this, or like this with a guide camera in the back here, to look at a star, and if there's any sort of movement with that star, it's going to send pulses to the mount to correct the mount's tracking essentially. Sometimes it might use multiple stars, but in this example, let's just say it's a single star. So the AM5N does have an ST4 port. Right here it says auto guide, but you're not going to want to use that because it's just very slow and really not that reliable. I do understand that there are some solar guide scopes, for example, that might use an ST4 port, but instead I would recommend doing direct pulse auto guiding, which will basically be where your guide camera is connected to a computer. So your acquisition computer, for example, computer is going to be connected to the mount here either by USB-B or USB-C. So you would need guiding software to make everything work basically. This can run simultaneously with your image acquisition software. So for the purpose of this video, I'm just going to be using 2 different telescopes and camera configurations. Since I have been testing this telescope over the last 6 months, I have used plenty of other telescopes with this mount, and those were kind of in the middle range. So I decided that it's probably best to show you kind of the lower end in terms of weight and focal length, and then also show you kind of the higher end of weight and focal length. So this is the RedCat 51. It's an earlier edition. It has 250 millimeters of focal length. So for the camera, we're going to be using this Canon T7 and this William Optics T adapter to connect it to the back of this telescope here. Okay, so then for our guide scope, we are using this William Optics 32mm Uniguide, and the guide camera that I used with testing is this ASI 290mm Mini, and then for image acquisition and guiding, I use the ASIair. Alright, so now I'm going to show you the heavier setup with the longer focal length. This is the Askar 103 APO. I am using the 1X field flattener. It just flattens out the field of view because this is a triplet refractor. I do have a video review of this if you'd like to check it out as well on my YouTube channel. And for the camera, it's an ASI 2600 MC Pro one-shot color camera. It's a dedicated astronomy camera, so it is a little bit different than this here. And then there are some adapters just to give it the right back spacing to achieve focus and get those round stars. Oh, and then for my guide camera and guide scope, this is the William Optics 50mm guide scope, and then I have the ASI 290mm Mini. So for the tripod, it's the TC40 carbon fiber tripod. I did use the PE200 Pier Extension off and on. There really wasn't much of a difference with the overall tracking performance of that. I mostly just used it because I am imaging on a balcony with a rail. Okay, so for guiding with the RedCat 51, I was imaging the Rosette Nebula, and I was not dithering, so I'm going to show some screen grabs really quick. So there is where the Rosette Nebula was for that night, and it's close to the meridian, close to the celestial equator. Again, that's the most difficult part for a mount to have to guide at because it's furthest away from the celestial pole. So for me in the northern hemisphere, that'd be the north celestial pole. So the sky appears to rotate much quicker. So I did create a plan, and I did have to calibrate the guide camera. Guiding calibration is really important. You want to make sure that you do that on the side of the meridian that your image or your target is going to be at, or at least tell the meridian flip to recalibrate. Speaking of meridian flips, there were no issues with meridian flips with the ASIair, at least. In Nina, you may want to enable it to continue tracking after a meridian flip. So these were just part of my guide settings. I was experimenting to see the best guide settings for my specific mount, and in order to tune a strain wave mount, you can check out Peter Zelenka's video on getting the most out of your strain wave mounts guide settings, and he also links some really great articles. So yeah, guiding so far looks really, really good. My RA aggression is 60%, my deck aggression is 50%. My exposure length is 1 second. I found that across the board, that just happened to be the best one for this mount. Polar alignment was also pretty good as well. I'm gonna fast forward. But just so you guys can kind of see. Okay, so this was a 600-second sub, so that's 10 minutes, and the guiding ended at 0.32 RMS, so really, really good. But I kind of would expect something like that with this. So here we have some guiding after I did the guiding calibration with the Askar 103 APO. It looks pretty good. Again, it's very close to the celestial equator and the meridian, and we're getting about 0.47, 0.5, same settings as before. A little bit of a jump there, not too bad. Again, I do live by a bunch of train tracks. Okay, so we are at M33, the Triangulum Galaxy, and like I said, I turned on dithering, put my dither settings on the screen here. Hopefully I don't forget to do that. And the sub exposures are 5 minutes long or 300 seconds. So we're starting off at like around 0.6. Looks like some RA jumps. A little bit of deck movement as well. So I'm going to scrub through this a little bit till we get to about like halfway through the image. So it's going down again, just these RA spikes, like right here and here. So I changed the aggression settings to 55%. I think that's why I did that. See if it made any difference. Yeah, so we're getting like a solid 0.5, solid. Things are really starting to settle down, 0.48. Mostly getting from 0.4 to 0.5. Okay, now I'm going to scrub through. Okay, now I'm getting down to 0.37, 0.36, 0.38. Okay, image is done, or dithering. So we should see a little bit of movement, some increase in the RA and deck. Oh, cool. So the max it went up is 0.61. There's a sub exposure. Looks good from this vantage point. And it is kind of slowly getting back down there. It's edging up a little bit. So it does take a little bit of time to like really settle after dithering. Just gonna scrub through a little bit until we get like, stars look good. Almost, yeah, about halfway there. So now let's review some of the images. Okay, so these are the debayered images, and stars look great. Absolutely no issues at all. No signs of trailing. Cool. I'm just gonna go to the center because if there is trailing, it's gonna be visible there too. You're seeing the movement from the dithering as well, just as a note. Might have to restretch. But yeah, overall these images look really good. So yeah, we've talked about a whole host of features and factors along with tracking and guiding and real-world performance tests. I did also use this mount unguided as well and was able to get pretty good images all the way up to 2 minutes with a pretty wide field setup, the RedCat 51 and the Canon T7. So if auto guiding is something that you don't want to really deal with just yet, and you do have a smaller setup, but you do want a strain wave mount to kind of get your bearings with, that is something to consider. So now I want to talk about price more. Here is my list of strain wave mounts. There are lots of different strain wave mounts, but I'm really trying to narrow it down to just kind of the leading competitors. We did talk about a lot of other features and how the AM5N compares to other mounts throughout this video. So we have the AM5N here, and then the next leading competitor is the Skywatcher 150i at $2,195 US, so about $200 more. It does weigh a little bit more at 5.8 kilograms, and it does have the same payload capacity without a counterweight, and it does have a larger payload capacity when you do use a counterweight. So for just $200 more, the Wave 150i gives you an extra 5 kilograms of capacity. So if you know you're going to need heavier gear down the road, that might be a better long-term option. You also have the HAE29 and the HEM27. The HEM27 is only an EQ mount. It does not work in Alt-Az and EQ like the HEE does. But the HAE29 B series come with something called iMate, which is a built-in computer. So if you're looking for kind of a more integrated, holistic system, I would recommend getting something like that. Now, should you spend more for a higher payload capacity? So if you already are looking into spending $2,000 on a mount, then if you have $600 to $1,000 more to spare, also keep in mind that you have to buy a tripod and make sure that you have a computer for all of the different parts of the workflow, like polar alignment and your image acquisition and guiding. But if that all is taken into consideration and you can front $600 to $1,000 more, then you can move into the next weight class, like the Ioptron HAE43 or the HEM44, and either of these options are going to give you about the same payload capacity without a counterweight that the AM5N gives you with the counterweight, and it's going to be about the same size overall. Other options to look into are the NYX101. The NYX101 can also come with the built-in Pegasus Astro power box, which is really cool as another integrated solution. So in terms of overall cable management, I think that that's a great option. But I haven't tested any other strain wave mounts, so at the end of the day, astrophotography in large part is about, getting as much imaging in as possible for at least most people. And for me, that is the biggest selling point for the AM5N, is that I can just trust that it's going to work pretty much every single time. But, what do you think? Would you go for the AM5N, or is there another mount you're considering? Let me know down in the comments, and I hope you guys found this video helpful, and if you would like some of the data to process on your own, you can check it out on Patreon. But until the next video, I hope you all have clear skies.